Hi students, Dr.V.Baala Classes. Make it easy chemistry. Organic chemistry, part 3, IUPAC Nomenclature. This is mainly useful for NEET, IIT, JEE and CBSE students. CBSE NCERT book, class 11, volume 2, page number 338. Today we are going to discuss about nomenclature of substituted benzene compounds. The IUPAC nomenclature of substituted benzene compounds, substituents is placed as prefix to the word benzene. That's why we are going to discuss about one by one. The first one, nomenclature of substituted benzene compounds. For IUPAC nomenclature of substituted benzene compounds, the substituent is placed as prefix to the word benzene. For example, here benzene ring, removal of one hydrogen atom with methyl group. This is called methyl benzene. First we have to mention benzene ring, then the attached group. Here attached group is methyl. That's a methyl benzene. The common name for this one is toluene. In the second case, OMe is attached. OMe is nothing but methoxy group. There is a mixed ether, aromatic and aliphatic ether. That is why this is mentioned as benzene ring. Methoxy group is attached. That's a methoxy benzene. Common name of this compound is anisole. Next case, hydrogen is removed by NS2 group, that is amino group, amine. Now benzene ring containing amine is called aminobenzene. This is also called aniline. Like that, nitro group is attached, nitrobenzene. Bromo group is attached, bromobenzene. That is why for IUPAC nomenclature, substituted benzene compounds, the substituent is placed as prefix to the word benzene. Next one is numbering carbon atoms. If benzene is disubstituted, the position of substituent is defined by numbering the carbon atom of the ring such that the substituents are located at lowest number possible. For example, this is a benzene ring. Here, disubstituted. Two bromo compounds are substituted at adjacent positions. That is why the first bromine is numbered as number 1, the second one is number 2. You write benzene, then prefix 1, 2 dibromo. That is a 1, 2 dibromo benzene is the name for this compound. The isomer of this compound is 1, 3 dibromo. One more compound is called 1, 4 dibromo benzene. That's why the benzene is disubstituted, means the position of substance is defined as numbering the carbon atom of the ring such that the substances are located at the lowest number possible. This rule is applicable for this structure. Another one is rules for dry substitution. If more than 2 substances are present in the benzene ring, if it is different groups are attached, means lowest local rule is followed. For example, substituent of the base compound is assigned number 1, and then the direction of numbering carbon atom such that the next substituent is get lowest number. That for that one is we have to follow alphabetic order. Let us see the example. This page is very important for benzene substituted compounds IUPAC nomenclature. For that, first we have to remember these 3 things. Already we name it as methyl benzene, methoxybenzene and aminobenzene. Whenever the methyl group is present in the alkane, that is open chain compound, it is simply considered as a substituent. But in the benzene ring, the methyl group attached means it will become a functional group. There is a toluene. Methoxy group, that is anisole. Amino group, aniline. But the priority point of view, amino group is greater than methoxy group, and the methoxy group is greater than methyl group. Apart from these three groups, the remaining groups like chloro, nitro, and some other groups comes means it is considered as a substituent. First example, this is a benzene ring is present. Here three substituents are present. One chloro and two nitro compounds are attached in the benzene ring. Here we have to follow two rules. First rule, out of these three substituents, no methyl group is present, no methox is present, no amino is present. That is why the remaining chloro and nitro, we have to follow alphabetic order. In this compound, chlorine C is present. That is why the carbon attached to chlorine of benzene is lowest number, that is number 1. The next one is, that is lowest possible number, that is second, number 2 is going to NO2. That is why we have to give numbering from this way. Then only we will get 1, 2, 4. 1, 2, 4 substituent. If you are going this way now, 1, 4, 6. That is why the lowest possible we have to take. That is why this is the correct order of arrangement. After that, second rule we have to apply it. That is alphabetic ordering. You have to write the name alphabetic order. C and N. First 1. That is why 1 chloro. Then 2, 4. Because two nitro groups attached in the second position and the fourth position, we are writing 2, 4 dinitrobenzene. Not 4 chloro, 1, 3 dinitrobenzene. First thing, first you have to follow alphabetic order while numbering. Chlorine gets number 1, number 2 nitro, number 4 nitro. Come to the second given structure example. Here three substituents are present, all are different. Chlorine is present, methyl and nitro. According to alphabet, the chlorine comes first, but here methyl group also present. Already we know that the methyl group attached to the benzene is called toluene, that is a functional group, considered as a functional group. Methoxy group and amino group. This is the order. That is why in this compound, that is methyl group is present. That is why methyl, the carbon attached with the methyl group of benzene, that is number 1. The chlorine is number 2, nitro in number 4. That is why 1, 2, 4 is assigned. Again, while writing the IUPAC nomenclature, complete nomenclature, you have to follow the alphabet. Even though there is methyl, get lowest possible number, you have to write chloro first. There is a chloro at second position, 2 chloro, then 1 methyl, then 4 nitrobenzene. In the third example, both methyl and methoxy group along with the chlorine is present. Here also three different substituents are present in the benzene ring. Now compare with these two. The priority, methoxy group is greater than methyl group. That is where the methoxy group is attached in the benzene ring gets lowest possible, number 1. That is why this is number 2, number 3 and number 4. Again the second rule. While writing complete naming, you have to follow the nomenclature based on alphabetic, but this group is called anisole. Benzene with O-methoxy is called anisole. We can write also anisole, otherwise methoxybenzene. The anisole containing two groups, chloro and methyl. Chloro at second position, that is C. Methyl at fourth position, M. That's a methoxy group. There is 2-chloro, 4-methyl, methoxybenzene, otherwise 2-chloro, 4-methyl. Anisole is the name for this structure. The fourth example, here also 3 different groups are attached as a substituent. Again benzene is there. In benzene, these 2 groups are attached. The priority NH2 group attached to benzene ring is greater than these 2. This is also called aniline. That's why we can say this aniline. The name of this compound is aniline. Aniline containing 2 groups, methyl and ethyl. Methyl at the second position, ethyl at fourth position. But while writing complete naming for IUPAC nomenclature, we have to follow alphabet. That is E first, 4-ethyl, 2-methyl aniline. Otherwise 4-ethyl, 2-methyl aminobenzene. This is the nomenclature for benzene substituted compounds. For this, you have to keep in your mind methyl group attached to benzene is called toluene, methoxy attached to the benzene is called anisole, and amino attached to the benzene is called aniline. These 3 groups are considered as a functional group. The priority point of view, aniline is greater than anisole. Anisole is greater than toluene. If any groups attached from this now, you have to give preference to that group. For example, here methyl is given first, 2 groups attached, that's why methox is given number least, then methyl and amino is present here, that is why we are giving number 1 to amino group. Students, this is very easy, I think. You can understand everything. Let us discuss next rule, benzene with the functional groups. For example, here benzene ring is there. Here also 3 attached group is there. 2 methyl group and 1 phenolic group. Whenever the phenolic group is present, there is a special functional group. OH is a special functional group like CO, OH and CO. That is why the carbon attached with the functional group get least number. That is why OH is attached the first number. That's why number 1 given to always OH. The remaining, the 2 methyl group attached to 3,4 carbon atom. That's why this is called phenol. Benzene attached to OH is called phenol. The name is called phenol. 2 attaching groups, 3 and 4 substituents present at the third and fourth position of benzene ring. That's a 3,4-dimethyl phenol. 3,4-dimethyl phenol. Now, from the NCERT book, the problem number 12.10. Here, some of the structures are given, how they are named as IUPAC nomenclature. Here, first in the benzene ring, any group is attached in the position, that is number 1 position, means the adjacent positions, 2 adjacent positions are called ortho. The one opposite position is called para. In between 2 positions, that is called meta. That is why this is ortho adjacent, next one is meta, opposite is para. In this question, write the structural formula of O-ethyl anisole. Already we know that what is called anisole. OMe is nothing but OCS3. This is a benzene ring. Here OMe is attached. This is called anisolic part. here O mentioned as ortho. What is ortho? Adjacent position. There are two adjacent positions, but we have only one ethyl group. That's why you can attach one ethyl group in the adjacent position of OMe, that is anisole group. That is why this is called orthoethyl anisole. Orthoethyl anisole. In the second structure, para-nitroaniline. Already you know that the benzene ring containing NH2 is called aniline. What is para? Opposite of NH2. That is called para position. What is attached? Nitro group. That's why nitro group attached at the para position. That is why the name of this compound is para-nitroaniline. Here, in the third example, here benzene ring is present, but both the functional group bromine attached only in the alkyl chain. For this, one new rule is there: when a benzene ring is attached to an alkane with a functional group, it is considered as a substituent. The benzene ring is attached with the alkane with the functional groups. Here, in this alkane, this is number one carbon atom. CH2, CH, CH, CH2, CH3. 1, 2, 3, 4, 5 carbon atom. That's why we have to write pentane. So pentane. Here, bromine and another bromine attached. That is why the least lowest possible is 1, 2. The bromine attached the 2 and 3. 2, 3. At the same time, benzene rings attached in the first carbon atom of alkyl group. That's why this will become phenyl. Whenever the benzene ring is attached to an alkane with the functional groups, it will consider as a substituent. Benzene, as a main chain is a benzene. When it comes to substituent, it will become phenyl. Phenyl group. Phenyl group attached in the 5-member carbon atom. Also 2 bromine is attached. That is why the name of this compound is 2, 3 dibromo 1 phenyl pentane. Because 1, 2, 3, 4, 5 carbon atoms containing 2 bromine at 2, 3 position and first position phenyl group attached. That is why when a benzene ring is attached to alkane with functional group, this will become phenyl. The next one is, here also 3 substituents are present: fluoro, nitro and ethyl. Here fluoro comes number 1, nitro 2 and ethyl number 4. That is why here you have to write alphabetically, that is final naming according to alphabetic order. Ethyl written first, 4 ethyl, then 1 fluoro, 2 nitro, that is benzene. Benzene ring containing ethyl group at 4th position, fluoro at 1st position and nitro at the 2nd position. That's why fluoro, nitro, ethyl is present. That is why these compounds are named as, first one is named as orthoethyl anisole. This one is naming as para-nitroaniline. This one is 2, 3 dibromo 1 phenyl pentane. This one is 4 ethyl 1 fluoro 2 nitro benzene. Thank you, students.